Have you ever wondered what the future really looks like? I don't mean next week or next year or even in 1,000 years. I mean the future of, well, of everything. Today, science is starting to paint this absolutely mesmerizing, mind-bending picture of how our entire universe will meet its end. So, let's embark on that journey together, all the way to the very end of time.
And that quote from Helen Keller, that's really our theme for this whole explainer. Because as we travel into this unimaginably distant future, a future that's going to be filled with cold and darkness and silence, we're going to find a truly incredible story. You see, the universe, it turns out, saves some of its most spectacular wonders for the very, very end.
All right, our journey starts right now. We're about to hit fast forward, watching eons just fly by. What you're about to see is based on our best current understanding of physics, and the destination is clear: the final, dying moments of the cosmos itself.
Okay, before we leap into the trillions and quadrillions of years, let's start a little closer to home. The next 250 million years are going to reshape our corner of the cosmos in ways that are frankly hard to even imagine.
Just think about this timeline for a second. In what is just a blink of an eye, cosmically speaking, our greatest achievements, the pyramids, will be nothing but dust. New islands will rise from the ocean. Mars will get a brand new ring. And the continents themselves will literally dance into a new supercontinent. It's just a powerful reminder that even on our own planet, the only thing that's truly constant is change.
And now we witness the first great turning point in the life of the universe. After trillions of years, the age of stars, what we call the stelliferous era, it finally comes to a close. And it all starts with our very own sun.
Yep, after billions of years of faithful service, the engine at the heart of our solar system, it starts to sputter and die. But believe me, it is not going to go quietly.
As that hydrogen fuel disappears, the sun's core collapses, and that triggers this final, furious wave of fusion. All that energy pushes its outer layers to expand into this monstrous red giant, which will just swell up and engulf the inner planets.
And that includes us. Our home, the cradle of all life we've ever known, is just vaporized by the very same star that once gave it life. It's an unavoidable, fiery end.
And just like that, it's over. All that's left of our brilliant sun is a white dwarf, basically a hot, dense stellar corpse, slowly cooling in the freezing blackness of space. And this is the fate that awaits every single star in the universe. One by one, all across the cosmos, the lights are going to go out.
So, welcome to the degenerate era. The universe is now this ghostly, haunted place. It's essentially a cosmic graveyard, populated by the corpses of stars, white dwarfs, super-dense neutron stars, and of course those silent gravitational titans we call black holes.
For a long, long time, the faint glow of these white dwarfs will be the only light left. They're like the last embers of a cosmic fire. But even that light is temporary. Over trillions of years, they'll cool completely, becoming what we call black dwarfs, just cold cinders of crystallized carbon. And here's a wild fact. This process takes so long that the universe isn't old enough for a single black dwarf to exist yet. Not one.
You know, you have to wonder, could life possibly survive in all this darkness? It's a pretty wild thought, but some scientists have speculated about it. Maybe some kind of life form with a biology that's completely alien to ours. You know, a conscious being that lives so incredibly slowly that a single thought takes 10 trillion years to complete. For them, this slow, cold universe would feel perfectly normal.
But you know what? Even those black dwarfs won't last forever. Over an almost unimaginable timescale, a process called proton decay will likely dissolve all remaining matter into pure radiation. When all that dust settles, only two things will be left in the entire cosmos: a few stray photons and black holes. The age of black holes has officially begun.
For trillions upon trillions of years, the only real events in the universe will be the slow gravitational dance of these cosmic monsters. And as they finally come together, they create something, well, something truly extraordinary.
So picture it. Two of these giants orbiting for ages, and then they finally spiral into this death dance. In the final fraction of a second, they're moving at nearly the speed of light. The collision is so violent, it literally shakes the fabric of space-time, sending out these ripples, gravitational waves, across the empty cosmos.
And this is where it gets truly strange.
The warping of space and time itself would be so intense, it would physically compress and expand the fluid in your inner ear. You wouldn't hear this in the normal sense, you would hear the sound of merging black holes with the very structure of your own head. The universe would literally ring like a bell.
You know, for a long time, we thought black holes were immortal. But the great Stephen Hawking discovered they have a flaw. Because of a quantum effect right at their edge, tiny particles can pop into existence, and one can fall in while the other escapes, stealing a tiny, tiny bit of the black hole's mass. We call this Hawking radiation. It's an incredibly slow process, but it means that even these cosmic behemoths will eventually evaporate.
And that brings us to the final act. In a universe that's been stretched to an unimaginable emptiness by its most mysterious force, the very last black holes will finally meet their end.
So what is this force? We call it dark energy. It's sort of like anti-gravity. It's a property of empty space itself that just pushes everything apart. And as the universe expands, there's more space, which means there's more dark energy. It's this runaway effect, just accelerating the expansion of the cosmos into a cold, dark, and empty future.
And here it is. After a period of time so long we have to measure it in Google years, that's a 1 with 100 zeros, the very last supermassive black hole finally evaporates. It goes out in a final, silent flash of light. This is the last significant event that will ever happen, the last thing to occur in the history of our entire universe.
This is the end, a state that physicists call heat death. It's an endless void, forever cooling towards absolute zero, containing nothing but a thin soup of stray photons. Entropy, the universe's measure of disorder, has reached its absolute maximum. No more change is ever possible. And if nothing can ever change again, well, then time itself loses all meaning. Nothing happens. Forever.
So what is this number? That is the estimated percentage of the universe's total lifespan in which stars can shine and life as we know it is even possible. All of human history, all the empires that will ever rise and fall, every single star you've ever seen, it's all happening in this infinitesimally small, precious little window of time.
But we have to ask, right? Is this really the end? Some physicists speculate that a hyper-advanced civilization could, in theory, create a new baby universe, a kind of lifeboat to escape into. Now, this is pure speculation, of course, but it leaves us with one last, profound thought. Perhaps the end of everything is simply the seed for the next beginning.